give you an overview of the design, and we can talk. If you can ask any questions, I'll give you kind of focus predominantly on the first mini design, but then I'll give you some insights into the second and third mini designs. Okay. So the way that this has been set up is it is a design for a fictitious city called the City of Evergreen. You've got two water sources, giving you water quality data for the Big Sky River and well number 10. And you're told that you have a series of objectives. You want to minimize secondary waste generation. So this includes sludge, it includes any air waste, any other waste. Really, those are the major ones. You want it to be cost effective, so we'll need to consider economics. You want it to be able to be permitted from a regulatory standpoint and acceptable to the general public. It's a little bit harder to do that in a fictitious setting, but I want you to at least think about what the general public would expect from a system like this. You'll need to consider all residuals that are generated to meet the federal regulations for land disposal. So basically, if you have any sludges that are, what will you do with those? How will you dispose of those? If they're land applied, then you need to consider the land application. And then you'll need to account for variations in the chemistry of the raw water. I'm not going to ask you to do a significant amount of process changes based on chemistry, but I want you to think about it and how that would impact your design. So you're told in the initial statement that the current population is 32,000 plus XX, 3 digits. And those 3 digits are the last 3 digits of one of your team members. So if you've got a team member with the last 3 digits are 789, you've got 32,789 people. Okay. And so that's the current population, and that population has increased at a linear rate of 1.5% per year. I've shown that to you here. There was some confusion with this last year, so I actually plotted the data. The assumption is I did this for current population of 32,123, and then back calculated the population in 2010. We're going to assume that the plan is to build a satellite campus of Ideal State University, and the enrollment in year 1 is 1,800, and the plan is for that enrollment to increase at 10% per year for 10 years, and then it would be constant. And the faculty-student ratio is 1 to 12. Now, why would I tell you that? And the answer is, the question is, will we be able to use other real cities in Michigan as similar models to look at when coming up with ideas? Absolutely. In fact, I'd be thrilled if you looked at other cities in Michigan or outside of Michigan to come up with ideas of how they dealt with problems like this. So why would I tell you what the faculty-student ratio is? Did I just throw that in there? Yep. Okay, more faculty needed for more students. Okay. Students aren't there year-round, but the faculty probably are. So if you know the number of students and you know the faculty, which include, okay, don't necessarily include staff, but there's staff associated. So you've got more people moving to the area. So that while the population is increased at a rate of 1.5% per year, Now all of a sudden you're building this campus, and I want you to think about how that would impact your population growth. Is it going to be at 1.5%? Or are you going to have, are they going to have to hire more faculty and more staff? What does that mean in terms of the population growth? They're also going to build a new 250-bed hospital. Does that impact population growth? I'm looking for you to make predictions and to justify those predictions. And you can look at other places that built a university and what impact did that have on their population. And then there's going to be a new public school, because if there's new faculty and there's possibly and students that may have children, so they need a new school. So they're going to build a new school. So there's significant changes within this community. The design period has been specified at 25 years. You can use a peak hourly flow rate of 5.3 times the average daily, or the maximum daily of 2.2, maximum daily flow equal to 2.2 times the daily average. There's also in your textbook a graph that if you go online, it has a point and click function on it. So if you want to use that, you may also use that. Based on your flow rate, you can then determine the peak hourly and the maximum daily. If you do, then just make sure you cite how you obtain those multiplying factors. One of the biggest issues is going to be your design flow rate, okay? Your population in year 25 is based on the anticipated rate of growth, and you need to justify that. So what I'm looking for more than anything is the thought process, is for you to think as engineers and document your thought process. You then will have to determine the anticipated water demand from the population, the demand from the satellite campus, the hospital, the school. Now you can start being creative. Do you think there's going to be additional commercial establishments resulting from the university? Okay, well, if there is, how much water do they need? And one of the biggest challenges in your design will be ensuring that your water treatment plant functions effectively in year 1 as in year 25. So you're going to have to look at 2 different time periods. You can look at 12 in the middle if you want to, but you, as a minimum, have to look to make sure that your plant operates effectively in both year 1 and year 25. And you want to think about that in terms of sizing of all of your processes. Okay? And you'll need to also consider maximum daily and peak hourly flow rates. Peak hourly flow rates, you only have to, that's really for pumping and piping networks. You won't have to worry about peak hourly in terms of the actual design of the system. You do have to worry about maximum daily though. In terms of estimating water demand, there are a number of tables in Davis. The tables are actually all taken from Metcalf and Eddy. These are samples of the tables that are in Davis. Tables 2-20, 2-2, 2-3, 2-4 are essentially these tables. These tables are actually from a book called Wastewater Engineering, Collection and Pumping of Wastewater. It's Metcalf and Eddy. It's considered kind of the Bible of wastewater treatment. And you can assume if the wastewater flow is X, the water flow is the same. So, for instance, if you assume, as it says, a boarding school is using somewhere typical is 280 liters per unit, so that's per student per day, then you can assume that the water usage is the same. So this is wastewater, but you can assume that the water usage is the same. You also need to consider reliability and performance requirements. So you want to discuss redundancy of equipment, tanks, power supply. These are based on the GLUM and the state of Michigan requirements. The PowerPoint that I've posted includes the link to the state of Michigan requirements. So you want to think about what do they require in terms of power, in terms of equipment. And then section 1-5 and table 1-3 in the textbook also will provide you with additional information. So when you're thinking about your design and you're actually proceeding, keep this information in mind. You're going to have to report it in the first memo, but you're going to need that information as you move forward. In terms of planning, what I will have you do is I want you to discuss what information you would need for planning purposes. Since this is a fictitious site, I'm not going to give you a map. I'm not telling you where it is. But think about how would you have to integrate with existing facilities. So for instance, if you look at the city of Cairo, they expanded their treatment plan a few years ago to include arsenic removal. So they had an existing plant. What did they do? Where did they put it? What do you need to consider when you're looking at siting that plant? So what information would you want? Whether it's information, we talked about some of this in terms of wetlands, hazardous waste sites. Think about that. What information do you want? And you're really just going to summarize this in the report. Are there issues with public perception? So if you look on a map of the East Lansing Meridian Township treatment plant, that was built on the edge of town when it was built. It's no longer on the edge of town. It has a very large nursing home, assisted living center right across the street. It has condos and apartments on the other side of the street. And they've had to make some changes because of where now being in the midst of a residential area. So for instance, they used chlorine gas. They now use liquid chlorine. It's safer, it's more expensive, but it's safer in terms of public health and well-being. You don't have to worry about a leak of a chlorine storage tank. Think about other, institutional issues. You've got a university. Is there a chance perhaps of integrating the water treatment system with the water treatment facility? One of the things that I've talked to the new plant superintendents for the MSU facility about is he's interested in, for instance, how he could create internships, even if it was only for a month or so, that students could actually spend time in the treatment plant so that they could get some better experience working in that plant. So think about things you could do there. And then obviously economics plays a very significant role in planning and implementation, construction and implementation. So in terms of mini design 1, you will provide a cover letter. Your cover letter is short and sweet. Doesn't provide a lot of detail. What you are doing is you are providing your expertise as the company that you have formed, and you're providing the report. So there doesn't need to be a lot of information in the cover letter. The cover page includes the information on your company, please include the team number and all of the names of the students. Makes it much easier when we're trying to deal with grading. And then you'll have an executive summary. That executive summary is really summary of your results, summary of your findings, and your recommendations. And yes, I will keep you posted. And actually, the plant supervisor will be one of the guest speakers. So you can talk to the plant supervisor directly. So in these design reports, these are not a research report. You are an engineer. You are providing recommendations. So when you're thinking about these reports, don't think of them as a research paper that you would provide for another course. Think about them as you're the engineer, you're hired to provide professional recommendations. So that's what you're providing. Your report, in this case, will include an introduction that includes your project scope and the objectives. In many cases, that's really a summary of what I gave you. Then it's your population and water demand predictions. What you provide in the report is what you want. Think of the townships or city mayor, the council members, head of public works. That's what they're going to read. So think about, how do you present your information in a way that is most accessible? Complicated tables are difficult to read. So think about, how do you summarize it? Put the calculations in the appendix. Put the summary of the data. Think about whether is a figure, the phrase, a figure is worth 1,000 words. Can you convey that information better in a figure than you would in a table? You'll then compare water quality and how does that affect your design. So there you're really going to look at the water quality and actually water quantity information that I've provided, and think about, does that impact your design? Are there particular contaminants that will be a challenge and that you will need to address? You'll need to look both at primary and secondary standards, because, for instance, if you have a highly colored water and you distribute water, it's kind of a greenish yellow color, you've got a community that's very upset. So you've got to address the color. So even though it's not an enforceable standard, make sure you're looking at the water quality and the water quantity information that's given. Reliability and performance requirements, you summarize the key aspects of these that will affect your design. Okay. And then planning, you're essentially, talking about what I mentioned. This is the information you need in order to make a recommendation. And then next steps. And then also, if you have questions, so if you have questions about this site, about the water quality data, provide that in your report. And I, as kind of your client, will also provide information. What I will do, okay, and I'm going to and I've done this before, unless you ask me additional questions, you're not going to get additional information. Okay. So you're going to have to ask, you lead. And then if you ask the questions, then I will provide further documentation. But you need to ask the question. And then, like I said, in the appendix, calculations, assumptions, complicated tables, those all go in the appendix. Design 2, mini design 2 will really get into the unit processes. So in mini design 2, you will be given some further information, but you'll be designing the rapid mix, flocculation, and sedimentation. Don't start designing that until I give you that additional information, because I will perhaps specify whether it's a surface water or a wastewater, surface water or a groundwater. I may tell you it's a blend of those two. So you can think about issues like sizing, but I will give you that information with design 2. And then design 3 will include filtration, disinfection, and activated carbon. You'll also need to think about the distribution system stability. You can start thinking about some of this early on. You have to specify it in design 3. So for instance, as part of your flocculation sedimentation process, you're going to be producing sludge. You can start thinking about what information do you need in order to dispose of it. Are there contaminants that would be, for instance, arsenic, that would be covered by land disposal regulations? So is there testing, for instance, that you would need to be doing in order to land dispose it? Are there other things that you would need to consider? One of the biggest issues right now are the PFAS chemicals, but this mainly has to do with wastewater. Although, for instance, if you had a groundwater that contained PFAS and you had to remove that, then you have to look at disposal of sludge. So PFAS chemicals are not included in the design, but these are things that could come up as part of your design, and they're things you would want to consider. So that's the design. Mini design 3 will be due, mini design 1 is due in the middle of October. Mini design 2 will be due in the middle of November, and mini design 3 will be due at the final exam. There's no final exam, just the completion of mini design 3. So that's how I'm working it, kind of middle of October, middle of November, and then becomes the middle of December. Any questions about my advice? You have your design teams. Don't wait. There's no reason. You have everything you need to start mini design 1, and you've got a rubric. The rubric is posted, and you can see how the rubric is aligned with what I'm asking you to do.
Dr. Maston, I have a question regarding the tutorial assignment that's due on Monday.
Actually, everything's due on Wednesday now because I moved everything to Wednesdays.
Okay.
Per
So for
popular,
that,
yeah.
what are the guidelines? Or like, it just looks like it says to draw a coagulation flocculation basin. So
Mhm.
is that really it? Do we look at the paddles lecture kind of that you talked about in that respect?
That's all I'm asking. So I've given you some. Um, I've given you the criteria. For instance, the number of paddles, or the number of blades, the number of paddle wheels per shaft, etc. So that is dependent or student specific. I've given you a flow rate so you can calculate a volume, so you can add dimensions to your diagram. So basically I'm asking you to, I'm trying to make sure that students can conceptualize what we've been talking about. So that's all I want is a drawing, and then with some dimensions on it showing these flocculators. So you should have dimensions, for instance, like the wall clearance, etc.
Okay, thank you.
It doesn't
Where
have
do
to
you
be
find that, like the instructions?
the, let me go out of here. Let me just go into the homework. Okay, the Dropbox I put there. I tried to make it straightforward, and then now I'm like, where did I? Okay, so what did I just do? Oh, sorry. Let's go back and share. Okay, so in the softening, and it's in softening because it was due at the same time as the softening assignment. So that's why I put it there. So what I've given you is the specification. So in this case, you're told that you're designing a water treatment plant to treat a surface water. Design flow rate is, in this case, 35,000 meters cubed per day. The water is to be pumped from a lake through an intake tower having 2 cells, and the water flows first through a coarse screen and then a fine screen. The water then flows into a rapid mix basin, I need space there, with a 3-blade axial flow impellers. So you've got to think about what this means. So I've told you about the rapid mix. Ferric chloride, I told you the dose. I give you the cross-sectional, so you've got a cross-flow horizontal shaft paddle wheel basin, and it has a detention time. Give you the G value. Tapered flocculation is provided, and you've got 3 compartments of equal depth and series. I give you the G values, and those will vary with the student. And that gives, in this case, an average G value of 50 inverse seconds. The compartments are separated by an orifice-type baffle wall, and the floor of the basin is level. and each shaft is to have, and I tell you the number of paddle wheels, tell you the number of arms on each paddle wheel, and the number of blades on each arm. Okay. So basically, it's very similar to what we did in class. What I'm asking you to do is, I'm not asking you to go through all the calculations. I'm asking you to, one, draw a schematic of the treatment plant showing chemical addition. So I'm asking you to take the words that are given here and do a drawing. Your drawing doesn't have to be artistic or whatever. It needs to convey the information. So you're conveying to me that you understand what's presented here. I didn't even, you don't have to worry about drawing the rapid mix basin. So I ask you to provide plan and profile drawings of the flocculation basins. That's just like we did in class. And then draw one shaft showing the number of paddle wheels, the number of blades, and the placement of the blades. So again, I'm trying to make sure that you understand the words and can picture it. Show the clearance, required clearance distances, along with basin dimensions. You don't need to do any additional calculations beyond the flocculation basin. You don't need to confirm that you would meet those G values or anything. I just want you to conceptualize it, okay? And then you'll upload the document into the associated Dropbox in the tutorial folder. It's in the tutorial folder because of the way that I set up grading at the very beginning. You don't need to provide any information in the essay text box. It's just there as a placeholder. So this is written, okay? This is just there to provide the information. So don't worry, you don't have to submit anything here. You'll submit your drawing in the tutorial. Does that make sense?
Yeah. Also, this doesn't require AutoCAD, right?
No, you
Okay,
can
cool.
if you want. I'm perfectly fine for you to sit down with a paper and pencil and draw it that way. You can do it that way. You can do it on PowerPoint. My goal here is not that you spend hours and hours with really detailed drawings. It's that you think about what this means, and you can convey to me that you understand what these words mean.
That was very helpful. Thank you. I did not know that the softening or the tutorial assignment was in the softening. I only saw the Dropbox, so I was pretty
Confused.
lost the direction. So I thank you.
Yeah, the only reason I put it in the softening was because I was trying to make it straightforward that when everybody did the softening, they remembered that it was there. I was trying to make sure that there was I didn't want that there was one more thing that you had to remember. So that's why I put it in the softening homework assignment folder. I don't know whether it was used. I don't know whether that was a good idea or not, but that was my thought process when I did it. Because I know that there's a lot to remember. Any other questions? Okay, if there's no further questions, then will end here. I will, as I mentioned, I'll download the recording. Give me a little bit of time to go through and edit it and splice it into pieces, and then I'll upload it. Okay, and I've got class this afternoon too, so, but I'll do it as soon as possible. Any other questions?